Hello, I'm David Hilster, and this is a talk on something I think is extremely important for all of us. And I really did think a lot about this because it was a conundrum, it was a problem I had to solve in answering the real question. Yes, it is a marketing question, and that's where it sort of came from. That is, how is it that we can have a group here and have 4 or 5 or 10 of us with different models of the universe? Is there a real explanation for that? So that's what this talk is about, and the talk is entitled 400 Years of Model Revolution. Why so many theories? I apologize, that should say so. Why so many theories? The dissonant world, we have the ether. Pretty much I see these are the classifications. When I made the Science Woke website, I had to classify these things, and I had the hardest time was the last one. But I put in force equations, but I don't usually use that. But the dissonant world models, and what I would say, competing theories out there, in my opinion, over all these years, that still are the ones vying for position and are valid. Alternatives would be the ether, particle, lattice models, force equations, and structures. I sort of put that together. What is structures? Well, there's some people who have models. I'll give you an example, James Carter, and he has rings, and those rings are made, and there are certain shapes that are very important, so I call those sort of structures that they build their universe models on. Right now, one has really not won out, although there's been a lot of work between and together, and of course, mainstream is actually no different. So this is hard for people to understand because we hear the word standard model all the time. So why is that? Well, here's a great example of how a person who is in the most prestigious place in particle physics and theoretical physics, and this is Sabine Hossenfelder. I have tried to contact her, but she doesn't seem to be interested in talking with us about this, but that's okay. I have nothing against that. And she wrote this. I first was knew about her when this article came out in January 23rd, 2019 in the New York Times. New York Times doesn't normally have these titles. The Uncertain Future of Particle Physics. And I put a quote down here from this. I used to be a particle physicist. For my PhD thesis, I did Large Hadron Collider predictions. That's the big collider, the biggest one in the world over in Europe. And while I have stopped working in the field, I still believe that slamming particles into one another is a promising route to understanding what matter is made of and how it holds together. That's sort of the way I would put that is, I don't want to offend everybody all at once. So I'm not sure whether she thinks that, but it's sort of maybe a political move so that it doesn't look too radical. But then she said, but 10 billion is a hefty price tag, and I'm not sure it's worth it. That's quite amazing to have from a person. So further on the article, I think there's some really good things. I'd like to read this. I think it's worth reading. The trouble is, a prediction in particle physics is today little more than guesswork. This is a person who was a particle physicist who got her degree to work in the Large Hadron Collider, folks. And she writes a book called Lost in Math. That's the first thing she did when he got up. And she says, in case you're wondering, yes, that's exactly why I left the field. In the past 30 years, particle physicists have produced thousands of theories. Now, when we get accused of having lots of theories, one of your answers can be, we've got maybe 5 types, maybe actively really working on real models at an extensive level, maybe 15, and a lot of those are similar. They're ether models, or they're particle-based models, or they're structure-based models. It says, produce thousands of theories whose mathematics can design to predict pretty much anything. For example, 2015, when the statistical fluctuation in the Large Hadron Collider data looked like it might be a new particle, physicists produced more than 500 papers in 8 months to explain what later turned out to be merely noise. So one of the things, again, we're not only in model revolution, they're in model revolution. We don't have a standard model. Oh, we're all, no, it's not there. Why would they be doing this? 500 papers to explain what turned out to be nearly noise. The same has happened many other times for similar fluctuations, demonstrating how worthless those predictions are. And then if you look at, this is part of an article for those who are watching on, you go to sciencewoke.org. I wrote an article on this, and this is now a talk I'm doing here because I thought it was very well worth it. Here are some mainstream is lost headlines. Here's the headline: How the quantum eraser rewrites the past space-time. Quantum eraser experiments state that a photon of light billions of years ago travels in a certain direction because the collective consciousness of beings billions of years after the fact. This is mainstream people talking, folks. Don't even try to understand this. This headline is public service brought to you by the folks at PBS who are doing their best to explain the unexplainable. Another mainstream is lost headlines. String theory may create far fewer universes than thought. Jeez Louise. String theory was invented as a mathematical executor to try to invent one particle upon which we could construct the entire universe. Some of the original creators of this exercise are horrified even to this day that it is taken seriously. The big science today, the theoreticians have created a bubble around themselves, talking in tongues of 11 to 19 dimensions while using a model of pure invention of mathematics that have little to do with the physical world. These are the headlines, and this is what I wrote about it in my article on Science Woke. This is a really good one too. Oh, you guys got electrical engineer with a model of the universe. Oh, this guy who used to be a judge has an ether theory that's describing light and gravity. What's that about? Well, take a look at this. Garrett Lissy is an American theoretical physicist and adventurous sports enthusiast. An exceptional, simple theory of everything. You'll see this come out in mainstream media once in a while. The surfer dude who has perhaps the unifying theory of all time. And it's 256 of something, I don't even know. But listen to how wonderful and simple it is. One new theory that's gotten attention is in the mass media is a surfer dude who's supposedly exceptionally simple theory of everything. Judge for yourself how simple. And this is a quote when I looked it up. Just look it up. A non-compact real form of the E8 Lie algebra has G2 and F4 subalgebras, which break down to strong SU3, electroweak SU2 times U1, gravitational SO 3, 1, the frame Higgs, and 3 generations of fermions related by triality. The interaction and the dynamics of this one form, the Gaussian value parts of the E8 superconduction, are described by curvature and action of a 4-dimensional base manifold. Now that's really simple. I'm sure the surfer dude's sitting on a rock somewhere. There he is. And what is this all about? Fame and power. That's all it is about. We want to find the next Einstein. You want to be the next Einstein, be smart, to actually give the world something truthful? No, you want to be the next Einstein so you can go around giving lectures for a lot of money and saying a bunch of nonsense. So, who talks about paradigm shifts? It's Thomas Kuhn, 1962, a physicist, an historian and philosopher, wrote one of the most cited books of all science, The Structure of Scientific Revolution. In it, he outlines his cycle on how science goes through scientific revolution. Kuhn gives examples of various scientific revolutions in the past. The Copernican revolution, moving the Earth from the center of the universe to the center of the solar system. Chemical reactions in atoms, it was a chemical revolution. And of course, the relativity revolution, which of course in this group is not that popular. Okay, so this is the Kuhnian cycle. Pre-science, that means before, we're just eating bananas and running away, not trying to get eaten by lions and stuff. I don't know. And then we get to normal science, then there's a model drift, then there's a model crisis, then there's model revolution, and then there's paradigm change. Once the models are whittled down to a model that people seem to think that's the best one, then you go back to normal science. So that's the Kuhnian cycle. And I'm going to talk specifically about the model revolution because I think that's exactly where we have been for a long time. Model revolution is the fourth step of the Kuhn cycle. In this step, a field's model of understanding is undergoing revolutionary change. The old model failed, which caused the model crisis step. The model revolution step begins when one or more competing new models emerge from the crisis. Voila! So, when someone tells you, what do you mean you're the group? You know, Duncan, everybody should, in the group should all agree on Duncan's model. Or they all should agree on the lattice model, Bruce Nappy's model. Or they should agree with the wave energy model of Jeff Yee. No, we are in model crisis. This step is a revolution because the old model usually is so entrenched in the mental habitat, in the mental habits, and even the lifestyles of those using it, a new way of thinking is incomprehensible and or unacceptable, at least at first. The model revolution step could also be called the search for a new model that works step. That is fantastic. That's why we are here. That's why we have this concert. That's why you guys give your papers. That's why I'm giving this paper. Because no one sees this. It's right in front of us if you take the time to look at it. I was answering the question, why so many models? Kuhn told us, but no one talks about that. Unless the step is driven, it says, the length of the step is minimized if the consequences to failing to find a new model in time are catastrophic. And that's one of the reasons I think we've been going for so long, because they're not catastrophic. Unless the step is driven by an appropriate process, it is almost always rocky, unnecessarily slow, and unpredictable. So we're doing very well at those things. I know, hard audience today. So this is David Hilster's reinterpretation of the Kuhn cycle. And we have normal science, we have model drift, and I put it at 1680, 1690. If you ask my dad what was happening at that time, you had normal science was Newton's mechanical world, and then all of a sudden they said, well, what's light? Maybe they're ultra-mundane corpuscles. What's gravity? Maybe it's a graviton, and it already started to drift the model right away. Then you go to a model crisis, 1905. Just pull that out of a hat. I don't know where I got that from. I don't need to explain that to anybody. Of course, that's Albert Einstein. I'm going to tell you why that's a model crisis. And then we're in a model revolution. I actually put it from 1690 to present because we have been in a model revolution that long, in my opinion. We're going to get to a paradigm shift and back to normal science. Maybe we'll never get there. Maybe we need to stay in model revolution the entire time. Maybe Kuhn was wrong. I didn't put that in this, but I said it, so. Model crisis. Albert dictated the laws to the universe, basically. In fact, if you look at this picture, this is one of his favorite quotes. And if you watch my movie, Einstein Wrong, I've got a brilliant composer in there who actually said, I need a theme song and music video for Einstein Wrong, The Miracle Year. Theme song? And I did not tell him what to put in it. And in there they say, and the facts don't fit the theory, change the facts again. And you can listen to the go to my EinsteinWrong.com, check out the music video, which is really hilarious. We kidnapped, my family kidnaps, including my mom, we kidnapped Stephen Hawking, which many people get offended by. And I think if Stephen Hawking would have saw it, he would have probably laughed. Anyways, if the facts don't fit the theory, change the facts. According to the science woke community, though, Albert Einstein was neither the start or the end of a paradigm shift. It was the start of Kuhn's model crisis. And this is what my paper and my talk is about. And then we get in what I call the particle invention. I am here today because of Dr. Karzani, who took 4 years of his life to undo in 1940 as a 20-year-old to when he was 24 to unravel what really happened with special relativity and decay, or what is commonly known as relativity. And what he discovered was, Pauli said, if you are going to make magical energy just because these stupid electrons that are bursting out of radium E, and they're going 0.86 the speed of light, well, you got to apply special relativity if you believe in it. And if you do, then it's going to have extra energy. Therefore, there's more energy than you see. And so Pauli said, oh, I'm going to call it the neutron. The true neutron, the name was taken. So he said, oh, I'll call it the neutrino, because they go to Italian and they start making it, neutron, small, and then he dies. Actually, that wasn't Pauli. I'm sorry. Fermi named it. I got that wrong. Pauli suggested it. Said it should be there if that's what you want to do. But he undid that knot. Until today, the neutrino is the bad boy of one of the bad boys. But it was invented. They said it had to exist. Quarks were invented. Strings. I read an article or saw them on TV. I don't remember when I was living in LA. They had a Caltech day for the public. They get on TV, or it was in an LA Times article. I can't find it. I've been searching it for 8 years now. But basically, the string theorists who started the whole thing, they get, oh, so sir, are you really happy about the Caltech public day? And they're talking about strings. What did he say? I'm horrified. We never intended strings to be anything but a mathematical exercise. And if you talk a lot about it long enough, like Michael Jackson sleeping in a Barometric chamber to make himself a different color, then yeah, you hear it enough, you're going to believe it. And that's what's sad. You see it today. You see people like Neil deGrasse Tyson saying, oh, we have Newton, but it breaks down in black holes in the Big Bang. Oh, then in the middle of the beginning of the Big Bang, in the center of black holes, that breaks down. We're going to use strings. What? They were invented. All these things were invented. Higgs boson, invented. Don't believe it? Don't ask me. Ask Dr. Alexander Unziker, a physicist himself, who wrote the book, The Higgs I always say that wrong, The Higgs Fake, and Bankrupting Physics. He's been very kind to be an editor, and he writes papers for our website, and he basically talks about how, in fact, we are in a place where we are inventing things. It's all mathematics, and of course we have Lost in Math by Sabine Hossenfelder. Okay, I want to give you an example here, and this was interesting. This is not in my article. Give NASA an example. NASA, like particle physics, was stuck in a one-solution only paradigm that worked for the moonshots, but then died. Really did. I mean, yes, they had the space shuttle, but we didn't go. When I was a kid, I was 9 years old when they landed on the moon, and I remember sitting in the basement watching a black and white TV and a very bad picture from the moon, and I'm thinking, my gosh, by the time I'm older, we're going to be living on other planets and other moons and all that. Didn't happen. Well, what happened? The disruptions coming from the outside. It used to be that you got all the engineers together, they brainstorm, and NASA would come up with a solution, and that's what we would do. And what happens? And this isn't the only answer. I just decided to do NASA because you can see disrupting is, Uber is disrupting taxis. Beyond Meat is now disrupting the meat industry with, fake meat, etc. So the disruptions come from the outside. We have multiple companies with multiple solutions to getting in space. And what happened? What happened? Well, the hope of the space race is now in reach, exciting and becoming reality. It was stuck. We have NASA's Mars habitat. I think this is in the middle of I wonder if I have I think this is an older version. But anyways, the 3D habitat challenge. So they basically said, we're not even going to do it anymore. We're going to throw this out to everybody, and we're going to see who can build a habitat on Mars, and they're all going to be made by 3D printing, because that makes the most sense. because you're not going to take the materials, and you're not going to have men there or women there actually doing it in the beginning. So what are your challenges? So they actually challenge teams to do this, and then they pick the winner. Well, we've got to change the public's mindset about physics in the same way. Physics and cosmology must be open to all, not just a few. Students should be encouraged to come up with new models of the universe. Why not? Dr. Carazani had an experiment it was the new radium E experiment, where you would, it was already half done by Buchner and Van de Graaff at MIT, I believe it was, in the 40s, and already showed the electron neutrino doesn't exist, which is supposed to be the biggest neutrino. But regardless, he had this really pretty easy experiment to do, and he had 2 grad students who were very interested in doing it. So he gave them the experiment to them, and they went to their professors. I want to write my master's thesis with this experiment. And they, both cases, same thing. He says, come sit down, sits in the chair in front of the desk, close the door, and they were asked this question. Do you want a career in physics? Yeah, of course. Then don't do this experiment. What kind of teaching are we doing as human beings? I mean, how ridiculous is that? If I were in the software class and I came up, I'm going to disrupt this entire industry. I'm sorry, you can't do that. You can't do. You'd be laughed at, and you would be probably taken out as a professor in the software department. But if you're in the physics department, you do this all the time. A lot of times when people are, because I'm becoming more publicly known, people come and say, well, Dave, you're not in physics, what's your degree in? He goes, I wish I had a PhD in physics, but I can't get one. What do you mean? Because the first thing I do is be writing on something that no one would probably accept in mainstream. And they should, because you should encourage students to challenge. We need to create critical thinkers. So we need to encourage people. We need to tell people that join this group, because do what you want. Come up with a better idea that's going to wipe all of our ideas off the page. That's what we should be doing with people. Websites like Science World, Natural Philosophy Wiki, the Natural Philosophy University. Those are seeds we're planting now, and there's not a course. The only course in the Wiki University that we have is how to make courses in Wiki University, which I made. But my dad and I are writing a book, and we're going to write a course in the particle model. If you like the particle model, do this. Oh, you get the 2 particles, things whirling around like this. They have an attraction. Why is that? Give us your answer why that could be physically. So we are changing. We need to change the public's mindset on all this. What is lacking in our endeavor is a focused way for new theories and to find new theories and models. We right now just let it happen. We talk about them. We argue amongst ourselves. Come up with a comprehensive list of requirements for all models and theories they have to address. Now this, to me, is interesting. Compare and judge those models. Can we do this? Can we do the same with papers, talks, video conferences, in-person conferences? Yes. That is, we can turn into NAS and say, okay, Duncan, you've got what I call the Vancouver theory of ether, and you always have to remember, especially if you win and I get credit for naming it. Okay. But you have to answer these questions with your model. Everyone in here. And I think we can come up with a comprehensive list. So I come to my last slide with the comprehensive list, or not, at least more. Ta-da! Not only are these are some of the things that my father and I have worked on. So the top 3 are the theory, or the things we already were working on. Light and gravity. If you're an ethers person, you come up with ether. That's a very light, based solution. Then how can gravity come out of that same system? I don't know who would be crazy enough to write a paper. Oh, wait a minute, we've got one coming up. So it's going to be really great to see how that person's doing a solution. It's a light with ether. How does gravity come Well, how does Michelson and Morley, or Michelson and Morley, the experiment, how do we explain that? There have been some people trying to explain that, especially with ether, entrained ether, etc. Right? But if you're the public, they're going to say, "Whoa, what about?" And I don't even have that one here. It should be here. Please add to this slide the first one, the double slit experiment, especially with the detector. Man, I think I had one set of slides with one that was newer. This set of slides was with that, and I think I have a newer one of this. I apologize. But regardless, what should be on this top of this second part of the list would be the double slit experiment with detector. Why, when you try to detect which slit, whatever is going through, whether it's a particle, whether it's a lot of particles, or whether it's waves in ether are going through slits, why is it when you turn this detector on, it looks like it changes from a particle to a wave? If I were a person who would be judging all these things, I would put that one down, because that's a problem no one can solve. We have a solution with our model, but I think everybody should take a look at it. Dispersion. Why does light change into a rainbow? How does refraction work? How does reflection work? How do you give physicality to magnetic fields? What about electricity and the circuits going on? What about color? What about charge? So the question is, these are just suggestions, but and this is my last slide, my suggestion is that we, as a group, come up with physical things that go on. So if I am a person who's a young person, and I think, wow, you got a model? Finally, we can explain the double slit with a detector. Can you? And if you are working on I will tell you, I've been around this organization for a long time. I've heard lots of theories who couldn't answer almost any of these, almost. Maybe one. And if we think about it, I'm not sure that's the best way about going about it. We sound more like NASA. Okay, everybody we're all engineers in a room, and we just do things. We don't have any criteria or anything. But I think that this will do two things, maybe three, but two things. One is to force the people who have models to look at this, and maybe that's going to change what they're thinking. And it's also going to give people who are new something to do and knock you off your position, or do better than you. So, to conclude, we are in model revolution. Not only are we demonstrating that, I think in a much better way actually, but the mainstream physics is in a model revolution. They are trying. Right now, everything is quantum gravity. Go to Sabine Hassenfelder, the lady who wrote Lost in Math, who is no longer at the Large Hadron Collider. She is talking about, now we have to make sure, how do we know what's the effect of gravity at the subatomic level? That's really what they're talking about. And so the quantum physics, quantum mechanics, quantum gravity, they have loop quantum gravity, they have all kinds of, I don't even want to list them all, but there's lots of them. So we are in model revolution according to Kuhn. And when someone asks us why there are models, you just say, we're in model revolution. The current model is in crisis. We have lots of data out there to go on, which we do, and we can then come up with models. And as they say, it can take longer times. Remember what Kuhn said in that one? It's going to take longer. It's going to be messy, and we don't know what the outcome is going to be. So again, I encourage us as an organization to use this term, model revolution, to use that term to help others understand why this is happening and why there isn't just one model of the universe right now. And that eventually, I'm imagining, that some model will prevail. And not only that, we as an organization, if we do this stuff, if we're the ones doing, oh no, I want to do my, oh there it is, sorry, laser pointer, there we go. If we're the ones that want to be ahead of the curve, let's make the rules of the game. And I'm not talking about the fix that we win, because that ain't gonna happen. It doesn't matter. Truth is truth, universe is the universe. But we should be the organization. Oh, well, the CNPS, they're the ones working on model revolution. They've been working on it for 20 years. Here are some of them. Here's what they put up as criteria. Because no one else is doing it. Okay, well, thank you very much. That's my talk. I filmed so many events that I actually, when I film my daughter's drama, and they don't clap in the right place after they do this beautiful scene, so sorry about that. Any questions or comments about this? No, my dad will just...
Yeah, they had one slide about comparing and judging or something.
Yeah.
It would seem better that that judgment sounds brutal and negative. It'd be better if we were talking about positive suggestions to improve the model rather than judging and ultimately saying, okay, you got a D and he got a C and so on.
Yeah. I think the word judge is a loaded word for sure, but I think one of the things is that it's not so much that we're going to judge and say his gets a B minus, yours gets a C plus, his gets an A minus. It's more that we do look to see what's good. We do look to see what seems to work. Because when you come out in the public, they're going to say, well, you're just going to work on them? And that's it? Yeah, we just work on it. We don't care if we get to an answer. We don't care if we compare them. But I think compare should be there. Maybe the word judge should. So, yeah. I think these are older slides. I'm looking at this and go, I wrote other stuff. I'm sure nobody here has had a problem, right? 6 versions of their slides floating around. Any other questions or comments? No? Okay, well, thank you very much.